Hello, Year 9. Welcome back to another video. We're going to continue in our stats unit, but today we're learning a new thing. We're learning about this thing called standard deviation. Okay, now standard deviation is a really useful figure for giving us an idea of how far apart or how spread a data set is. So this is used all the time in scientific analysis, and in all sorts of things as a way of describing data. So it's a really, really useful thing to learn how to do. What we're going to do today is we're going to learn about its definition, how it's calculated, and we're going to do that manually, which you'll see is quite can be quite onerous. And then we're going to learn how to do it on our calculator, and we're going to thank God for calculators and that we don't have to do it manually all the time. Okay. But it's important we understand what it is, how it's calculated, so that we can, understand how to use it and when to use it. Okay, so what is standard deviation? It measures the spread, or in other words, how far away is each data point from the mean. So let's say you've got a whole set of data. We want to think about, well, is there a way we can calculate something where we're comparing every point in that data set to the mean of that data set. We're trying to figure out what's the space between every data set, and then what is going to be the sum of those spaces, or the average space from every data set from the mean, if you will. And what's that going to, that's going to tell us, well, how far apart are most of the data points from the mean? Are they going to be close together so that it's a very tight sort of clustered group of data, but the mean is very close to each point, or is it going to be really spread apart where each point is actually quite far away from the mean or the average? So let's look at this formula here. Now, there are some symbols here. This is probably the craziest formula you've ever seen, but let's just break it down. What does each symbol here mean? Well, the simplest one here is n, which we should recognize is just the number of data points in our set. So number of data points in our set. Okay, that's what n is. Now, this little funky symbol on the left here is called sigma, and it's kind of like a little circle with a hat on top. We call it sigma. It's a Greek letter. It's the Greek letter that is our S, okay? And it stands for standard deviation. Okay, so S for standard, except we're using the Greek letter sigma instead. Standard deviation, which is what we're looking at today. So the standard deviation of n, that's what the subscript n, so of that many points of data, is equal to, we've got the square root, g, of, and then we've got this funky symbol here again. Now this symbol here is actually capital sigma, and it just means the sum of. So it's shorthand of saying add up all of these points, so the sum of. It sort of means repeated addition, is what that big thing there means. Now x is just a data point. And then x with the little bar on top, or the little hat, or x hat, if you want to call it, is the mean, which we know is the same as the average of that data point, okay, which is there. So what's happening here? Well, the standard deviation of n is going to equal the square root of the sum of the distance between each data point and the mean squared. Okay, and then we're going to divide that by n, so we're kind of finding the average distance between a data point and the mean. That is what we're doing here. So it's a very funky looking formula here, with lots of different symbols, but we need to know these symbols. We need to know what sigma is. We definitely need to know the sum of the big capital sigma, and then x bar or x hat, we need to recognize just means the mean. Okay, so if you see x hat or x bar, just calculate the mean is what it's asking you to do. Okay, so we're going to do one example of this using this formula to calculate the standard deviation, and then we're going to do the calculator method. So firstly, we need to put in each score, and then we're going to find the difference between each score and the mean. So firstly, let's go 6, 6, 6, 8, 9. There are scores in this particular data set. Now to find the mean, we've got, sorry, I've missed 1 and 10. To find the mean, we just simply add up all the scores. Okay, 8, 9, 10, and then divide it by the number of scores. Now there's 6 scores there. So the mean is going to be 7.5. So what we're going to do here, for each of these x minus x hat, it's just going to be that x, or that data point, minus the mean. So in this case, it's going to be 6 minus 7.5, which is negative 1.5. Okay, and that's going to be the same for this. We won't write it all out for these ones. Negative 1.5, negative 1.5. Okay, and then here, it's going to be 8 minus 7.5, which is going to be 0.5. Okay, and then 9 minus 7.5 is going to be 1.5. And then 10 minus 7.5 is going to be 2.5. So there we found the distance, or the difference between each data point and the mean accordingly. Now, we need some way of normalizing these differences to compare them. We want to make them positive. So we've got some that are negative and some that are positive. Now, a really easy way of turning things into positive numbers is to square them, because a negative times negative is a positive. And so when we square this difference, we're then going to get the same answer in a positive number. Okay, so negative 1.5 squared is just 2.25. So that's what those ones are going to be there. And 0.5 squared is just going to be 0.25, as you can see. And then 1.5 squared is also going to be 2.25. Doesn't matter if it's positive or if it's negative. And then finally, 2.5 squared is going to be 6.25. Okay, now to find the sigma of all of these, we need to add all of these numbers up. Okay, so we're going to add them all up. So it's going to be 2.25 plus 2.25 plus 2.25 plus 0.25 plus 2.25 plus 6.25. And we have our sum of all those differences, which is 15.5. Now, to find the standard deviation, we're almost there. We found this part here. We just got to do the square root of that over n. So then sigma n is going to be the square root of 15.5 over, and n is 6. We have 6 scores. That's going to give us our standard deviation, believe it or not. So square root fraction 15.5 over 6 equals, okay, and often you're going to get a number that's quite long, so often you'll have to simplify it to 1 or 2 decimal places. We're going to go to 1 decimal place. So 0.6, 1 decimal place is our standard deviation. Okay, pretty crazy that we had to do all of that just to find out one number. So thankfully, there's a way we can do it on our calculator. Now, using on the calculator is also a little tricky. So I'm going to walk you through it, but it is easier than doing it manually like we just did there. Okay, so the first thing that we need to do is we need to turn the calculator on stats mode. So if we look up at the top right, we see mode. We're going to click mode, and then we're going to click 2 for stat. and then we just press AC. So now you can see there it says stat at the top of my calculator, and it should for you too. We're now in stats mode. You need a Casio calculator to do it this way. If you've got a different calculator, then it's going to be different. But for most of you, we'll have a Casio because that's the one the school gets. Okay, now to input our data, we need to create a table, and we're going to go Shift, and then down here just above 1, and it says stat above there, we're going to go Shift, and then stat, and then we're going to select data for 2. Okay, and you see here now we've got a table here in which we can input our data into, and then the calculator will sort of hold that data and save it. So X, this column is just the data point, and then you just got the number data point there. So data point 1, data point 2, data point 3 as you go down. So what you need to do is just put the number in. So the first data point is 6, and then just press equals, and it will enter into your table there. So let's do that again. 6 equals 6 equals, okay, and then 8 equals 9 equals 10 equals. So now it's stored in our calculator. We can clear that. Don't worry, the calculator still remembers. And then we can calculate our standard deviation from that. Now the way we do that is we go Shift, Stat, and then we want to look into var. Okay, and now here we have a whole bunch of different things we can find. We can find the number of data points by pressing 1. We can find the mean by pressing 2. But what we're interested in is we're interested in sigma, the standard deviation. So when I press 3, guess what's going to happen? It comes up on our screen, and then I can press equals, and we have our standard deviation here. And you can see there, I was correct in the way that I calculated it from the table. So that's how you do it using your calculator. So let's do that again one more time, just so that you're clear. Or you can re-watch that if you want, but we're going to do this question, example question here. So input data, select data. So we're going to input the data into the table, input the data into the table. Okay, clear by pressing AC, and then press Shift, Stat, and then we're going to go for var, and then we're going to press, the last thing we had to do was 3 for sigma, which is your standard deviation. So there are your kind of 5 points that you need to do to work this out. So let's do this again. Now to clear your memory, we need to go Shift 9, and then clear all memory, and then yes, and then AC to get back to where we are. So now we've cleared, so we've got rid of that table, so we can make a new one. We're going to go Mode, turn it into Stat mode again, and then AC. And then we're going to go Shift, Stat, Data, so that we can enter our data points here. So let's do this example here. We're going to go 12 is our first data point, 13, 14. Got a few 14s. Gonna add one more, and then the last one, or last 2 is 15 and 16 equals. Okay, then clear that by pressing AC. We then go Shift, Stat, var, which means variance, and then we're going to go 3 and press equals to get our standard deviation. So our answer for this one, sigma equals 1.2. Let's do it to 1 decimal place. Okay, so it's a little tricky, but definitely easier than doing it manually. I hope you've enjoyed this video. Good luck with the questions. If you do have questions, do message me. I'm happy to do more example questions by video upon request. So make the most of that, and I'll see you in the next video.